All right, we are continuing on with our forces chapter. We're on the tail end here, so you guys have drawn free body diagrams. We've learned about objects in motion staying in motion. You've done some calculations and understand how net force makes objects accelerate. Hopefully now we've started to really understand what gravity does and how someone's weight can change. Our last little stretch here involves Newton's third law, which has a lot of really important real life implications. I'm sure you guys all remember from 7th through 8th grade, for every action there's an equal and opposite reaction, but we really want to take that understanding a step further with you in high school. It won't be as easy as it was in class, but we'll go through some examples here. So what your textbook really says that Newton's third law is that when an object exerts a force on a second object, and remember, forces are usually on something, that second object exerts a force equal in size. So if I push on the wall with 10 newtons, it's 10 newtons back onto my hand, and there's that opposite direction. That's very, very important here, and there's a lot of misconceptions about this. The main thing is that we understand forces always occur in pairs. Sometimes Newton's third law is called the law of partner forces because it's always force of A on B and the force of B back on A in the opposite direction with the same magnitude. So a lot of kids will say, well, what is this really saying here? Like, here's some really simple real life examples. I mean, when I punch a wall, I clearly apply force to that wall, but it hurts my hand afterwards, and that's evidence that shows me the wall exerts a force back on my hand. When you swim in a pool here, I probably won't be able to show this on my little webcam, but when you actually stroke in the water, you push the water back. It's the water pushing back on you that makes you go forward. Okay, there's a lot of movement examples like that. Kicking a ball is the same way. I mean, it hurts my toe because the ball exerts a force back on my toe as I apply a force to the ball. Running, there's a lot of really good examples. I mean, when I hit the ground and I push into the ground, why do we bounce up? That's because the ground pushes back up on me. Even the whole idea we talked last mass and weight video, when I hold a fish up, we know that fish exerts a force downward on the scale, but the fish doesn't fall because the scale exerts a force back up on the fish. So it's always that idea of opposites. Okay, even a rocket ship's a great example here because when that rocket has those engines thrust, it pushes gases out and down, but the rocket moves up because as it pushes on those gases get pushed back up by air molecules, which is what pushes the rocket up. Really, really oversimplification there, but those are some really important real life examples. So looking at this a little bit more here, it's important. A lot of people will say, well, if I have a bug in a bus, that doesn't make any sense. How does a bus exert a force on a bug and the bug exerts the same exact force on a bus? The reason why is because it's not always equal effects, and that usually comes down to the objects being different. So your textbook talks about, well, if I drop a ball, we know that the force of gravity pulls it down. Well, technically then the ball also has a force on the earth. So why do I see the tennis ball fall, but the earth doesn't do anything? And the reason why is because they have different masses. So if we go look here, the force of the earth on the ball is equal to the force of the ball on the earth. A lot of kids miss this question because, oh, well, the earth is so big. But these are partner forces. See how the words are just flipped around? That's what Newton's third law is, equal and opposite. That's what this is all about here. Now we know from Newton's second law that force equals mass times acceleration. So we know that the force of these two things are equal, but hopefully this little example will show you. When I go look at the ball, it has a really tiny mass. It doesn't weigh very much, a tennis ball, which is why it accelerates so fast. When I go look at the earth though, its mass is huge and its acceleration is so tiny that we can barely even notice it. These letters kind of show that opposite effect. Because this mass is so small, the acceleration has to be big. Because the Earth's mass is so huge, the acceleration has to be small. And that's how they can have the same force there. Hopefully those letters kind of help you think about that. So just remember, as you go into these problems, no matter how tricky it sounds, the force of A on B is always equal to B on A. And I'll put one or two more videos up that'll help you guys kind of understand this, but that's what Newton's third law is all about, and it's acting on opposite objects, which is why there's so many misconceptions about it, but always opposite in direction and equal in magnitude. Watch one or two other practice videos and you guys will do just fine on your quiz. Good luck.